to be telling you about Alexander Fleming and the discovery of antibiotics. So, Alexander Fleming was born on the 6th of August 1881 in Scotland. He was born into a relatively poor farmer family who did not have much. After finishing school, he went on to study at the Royal Polytechnic Institution and worked in a shipping office for a few years. Later, he would inherit some money from his uncle and would go on to join into the St. Mary's Hospital Medical School to follow into the footsteps of his older brother, Tom Fleming, who was already a physician at the time. In 1914, when World War I broke out, Alexander was commissioned as lieutenant and was later promoted to captain in 1917. Fleming thus served through all of the First World War in the Royal Army Medical Corps and worked in many battlefield hospitals on the Western Front. He saw hundreds of men succumb to bacterial infections of wounds and bacterial illnesses that could not be treated at the time. In 1918, he returned to St. Mary's Hospital, where he was elected Professor of Bacteriology of the University of London in 1928. Now picture this, London 1928. A group of mold spores surf a breeze through a lab. They drift onto a petri dish, and when they land, they germinate a medical revolution. This lab belongs to Alexander Fleming, who at the time was investigating the properties of infectious bacteria. At the time, Fleming was away on vacation. When he returns, he finds a colony of mold growing on a petri dish he'd forgotten to place in his incubator. And around this colony of mold is a zone completely and unexpectedly clear of bacteria. In studying this mysterious phenomenon, Fleming came to realize that the mold was secreting some kind of compound that was killing the bacteria. The mold was a species in the Penicillium genus, so Fleming dubbed the antibacterial compound penicillin. What Fleming stumbled upon was a microbial defense system. The Penicillium mold constantly produces penicillin in order to defend itself from threats such as nearby bacterial colonies that might consume its resources. Penicillin destroys many types of bacteria by disrupting synthesis of their cell walls. Penicillin prevents the reconstruction of the cell wall, which is constantly being broken down and rebuilt as it fights off invaders. Meanwhile, penicillin stimulates the release of highly reactive molecules that cause additional damage. Eventually, the cell structure breaks down completely. This two-pronged attack is lethal to a wide range of bacteria, whether in petri dishes, our bodies, or elsewhere. It's not, however, harmful to our own cells because those don't have cell walls. For a decade or so after Fleming's discovery, penicillin remained a laboratory curiosity. But during World War II, researchers figured out how to isolate the active compound and grow the mold in larger quantities. They then went on to win the Nobel Prize for their work. Teams at Oxford and several American drug companies continued development, and within a few years it was commercially available. Penicillin and similar compounds quickly transformed the treatment of infections. For the time being, they remain some of the most important life-saving antibiotics used in medicine. However, the more we use any antibiotic, the more bacteria evolve resistance to it. In the case of penicillin, some bacteria produces compounds that can break down the key structure that interferes with cell wall synthesis. Nonetheless, penicillin, as well as many other antibiotics, have saved millions of lives since their accidental discovery by Alexander Fleming. They are perhaps one of the most important medical breakthroughs of the 20th century. Our world will not be the same without them.